Welcome to our webinar on what's new in Itasca Software version 9.4. This is Jim Hazard, Software Development Manager here at Itasca. So just a little bit of preliminary information here. Version 9.4 is obviously the fourth point release since we released version 9. These point releases are something a little bit new for us. In the past, we've just had major releases like 6 and 7. These point releases are a way to provide you with new features and new developments as they get completed, and we can get them into your hands more quickly between these sort of major releases like the 6 and the 7s and the 9s. This is advantageous because obviously it allows you to get the new features more quickly and start using them. It's also beneficial for us because we can get feedback on the new features and we can adjust our development plans accordingly and try to create a better experience for the user. I should mention that these point releases are only available through subscription or a maintenance plan. And I should also mention that this is completely back compatible. So if you have data files or save files from previous versions, you can, of course, run them or open them in version 9.4. Okay, so here's the list of new things in 9.4, or at least the things I'm going to talk about. The object tree, I'll describe what that is in a minute. Some new plotting capabilities in 2D, some new improvements for the sketch tool, a new tool for looking at Hoek-Brown failure envelopes, some capabilities for structural elements, a new constitutive model, and some new examples. Okay, so the first thing is the object tree. What this is a way to give you visibility into the things that are in your model. You can see what's in there, you can look at the values, you can query them, and you can do other things with all of the items that are in your model. And so rather than me just describing it here, I will demonstrate in the software. Okay, so this is FLAC2D. This is one of the examples from the manual, this wharf example. I should mention that this object tree is available in all of the programs that are part of this package. So that would be FLAC2D, FLAC3D, 3DEC, PFC2D, PFC3D. Okay. The window here looks more or less the same as it has before. What's different though is the left-hand side. Okay. So let me expand this out a little bit. I can increase the font size here. And we can just zoom in on this tree on the left-hand side. So what you can see is that under project, we have the same thing that we had before. Okay, data files, plots, save states. The main difference here is that they are expandable, right? So I can expand and contract these different items. They work the same way as they did before. So I can double click on one of these data files and it will open it up here in the main window. I can double click on one of the plots. It will open it up in the main window. I should restore a state here so I can have something to plot. So again, if I double click on a save state, we'll actually restore that state. And there we go. Now I have some pore pressures. What is new, however, though, is that I have a little bit more control over where my plots and data files appear in the main window. So I could take one of these items and drag it and choose where I want that thing to appear. So if I'm a little bit towards the left, it will automatically split the screen and create a new plot. I could do the same thing above. So I could go a little bit above here and it will split the plot this way. And so just by dragging and being careful about where I put things, I can arrange my windows any way I like. All right, let's close these. Let's open the data file again. Now, where it gets interesting is when we drill down into the model state. Okay, so if I expand this, you can see here are the things that are in my model: fish functions, histories, a sketch set, some structural elements, 2 tables, and 684 zones, right? And you can start drilling down here to see, more details about what you've got. So I can expand this, and I've got 4 fish functions, 1 operator, 8 symbols. I can see what those symbols are and what their values are. Now, this is a bit similar to what we already have in terms of the global fish variable visualizer over here. One of the cool things, though, is that I can choose a specific fish variable and watch just that one variable, right? So now I could run this model and watch all these things change, which is fine. But sometimes you might have dozens or even hundreds of these things, and it's a bit hard to see what you want to see. Maybe I'm only interested in, say, this one thing here, this D. I can right-click on it and say watch, and it actually appears down here under watch. And so there might only be a couple of things that I'm interested in watching while it's cycling, and I can just add them to this watch list down here at the bottom. It's not just fish functions or variables. I can do that with other things. So let's drill down into the zone information. This is where it gets interesting. Right, so here's this sort of high-level information about zones, the range and densities, and it actually tells you the ID of the zone with the minimum density and the maximum density. Same thing with volume. This is super useful if you're looking for zones with bad volumes, or zones with high stress or low stress. Right, you instantly get this visualization of the maximum and minimum of these different things. If I look at the grid points, then I can look at information like displacements and velocities and accelerations and so on. And this is all super useful. Now, as well as being able to just see them in the tree, I can do other things here, right? So I already showed you how I could do a watch. So let's say, for example, I want to keep an eye on acceleration. I could just right-click on that and say watch, and it will also appear down here in the watches. Other things that I can do here is I could drag things for plotting. Okay, so let's say I go back into my zones, and let's say I want to look at let's say I just want to look at zones. I can click on zone and drag it over here, and it will make a new plot of just the zones, right? If I want more detail than that, I could, for example, choose the, drill down into the material properties and choose cohesion and drag that over here. And now I've got a plot of cohesion, right? So it's just a very quick way to plot things without having to, find them on the plot tree and change the attributes and all that kind of stuff. As well as dragging for plotting, I can drag for printing. So I won't do it for zones because there are a lot of them, but let's look at the structural elements. So here I've got 16 pile elements. If I drag that to the console, it actually prints information about those elements here, right? And again, I can be more specific. If I expand this and say I want to look at the coupling normal stress, I can drag that down here and get information about that in the console window. So I can drag for plotting, I can drag for printing, and the last thing I can do here is right-click on something and get help about it. So if I right-click on where it says pile and say help, it will actually open the section of the manual related to piles over here in the help. And of course, I can click on this button to open it in a browser if I prefer. And again, I can be more specific than that. So for example, pile groups, if I right-click on that and say help, it takes me to the command entry in the help manual related to setting the group names for the piles. Okay, so this object tree is super useful for looking at your data, plotting things, getting information about them, getting help, all this kind of stuff. You can set it up so that these things are changing while it's cycling, because sometimes you might want to watch how things are changing while it's cycling. If you don't want to do that, you can also just pause it and have it not do that. The last thing I'll say about this is, again, you can turn on and off the different things that are visible here. If you don't like the tree for some reason, you could choose to, not show the model part of this, or the other things. And then you're left with basically what we had before. The last thing to say about this is there's a help button here, a little question mark. If I press that, it takes me to the section of the manual about how to use the tree. And there are also some nice little videos here, very short videos about how to use the things in the tree and how to do the plotting and other things that I just briefly touched on. Okay, so that's pretty much what I want to say about the object tree. Hopefully you'll find that useful. Well, I'm in FLAC2D here. I will just point out a couple of other new features in 9.4. Okay, so let's make a plot of, let's bring my tree back again. And let's, for example, make a plot of zone, well, okay, we've got the zones here. Let's, or I've already got a plot predefined here for displacement. So let's just open that plot. So here's a plot of displacement. This is a contour plot like you've seen before many times. What's new is if I go into the contour controls under the attributes, there's a checkbox here for ISO lines. So if I click that, what it does is it draws these black lines at the boundaries between the different colors. And this is just a really nice way to sort of visualize, maybe where you're changing from one value to another within your model. You can also have labels on there. So let's expand this. Right, there's some text labels. Let's make the font a little bit bigger. Right, so again, it just shows you where the boundaries are between different values of whatever it is that you're plotting here. I can turn those labels off if I don't like them. And I can change the font and the style and everything else. So, so that's one new thing. Another new thing, let's just turn those lines off. Another new thing is a new plot item in 2D. So if I go up to plus here, I can choose grid point. This one is new. So if I double click on that, it actually plots a square where every grid point is. These are a little bit too big to see, so let's make them smaller. Right, so it's got a little bit of a square on top of every grid point. Right now, they're all the same color, but this could potentially be useful, for example, if you have groups assigned to the grid points. Like maybe you gave them a group name, so you could apply boundary conditions. So I could change this label to show groups. In this case, they don't have any groups, but you can imagine if I labeled these as like bottom or side, then I would be quickly able to visualize, what the groups are. I can also, if I want to actually contour these instead of label them, so I can change this to a contour, and let's hide the background zones. So now I can see all the grid points contoured by some value. This could potentially be useful too. Okay, well, I've got this open. A couple of other things to show. There's some new capabilities in the sketch. Let's just make a new sketch set. New sketch set. I'll just call it test. Okay, so here's the sketch. Hopefully you've seen this by now. We have some built-in tools, and hopefully you've seen all of those by now. One of them is the slope wizard. So if I click on that, right, I can make different shaped slopes by choosing different things from this drop-down menu. The new one in 9.4 is this open pit. So if I choose the open pit, what it allows me to do is have these multiple benches with a relatively narrow width, and then multiple ramps with a larger width. So you have this kind of like a two-tiered structure that is more representative of what an open pit actually looks like. And then I can give this sort of overall angle, which is often what you're interested in when you're trying to model these open pits. So I can fill in these different parameters and get a 2D model that sort of is representative of the way that these open pits are actually constructed. So let's just do that. So here's what it might look like with the default values. Of course, I can change things to get more benches and more ramps and different geometries and so on. The other new thing in Sketch is, let's go back up to the tools here. And there's a Voronoi block tool. This is not new. In the previous 9.3, you were able to create Voronois inside of any closed shape, and then turn those Voronois into actual joints. So you have something that looks kind of like a UDEC model. So we can do that. I'll just show that again. So let's select the slope here. And then using the default parameters, I can just look at what that would look like for Voronois by hitting preview. So I could create a model that looks something like this. What's new in 9.4 is this button here that says triangulation. So instead of Voronoi, maybe you just want triangles. So I can choose that option and hit preview. And instead of Voronoi, I have triangles. So that's the new thing in 9.4. And again, I can turn all these triangle edges into actual zone joints or interfaces and see them sliding and opening and things like that. Okay, cancel that. Let's go back to the model that we were already looking at. So I'm going to close this sketch. Now here's the model state. I want to talk a little bit about structural elements. So in this model, we have all kinds of different things, beams and piles. Let's just plot the piles by dragging them over to this window. So in this case, I have two piles. It's plotting them by a group name, but let's change that to contour. So it's contouring by displacement. Let's maybe change that to a force, right? So I'm plotting today's piles contoured by force. None of this is new. What is new is that I can right-click on this plot and say export the one-dimensional structural elements. And what it will do is it will export the data that you're visualizing on this screen to tables, right? And it will allow you to plot the data in a table so you can see, force versus distance along these cables, or sorry, along these piles in the table plot. So if I just add a table plot here, table chart, and I can put on these two tables that it just created, right? So here's the force versus distance in one of the piles, and here's force versus distance in the other pile. And you can imagine in a more realistic model, you might have, dozens or hundreds of these things, and you can put them on tables and look at them. This works in 2D and 3D and 3D. All of the programs that use structural elements, the same logic will work. And of course, once I have them in tables plotted, I can just right-click on this and say export to a CSV, and I could play around with it in Excel or whatever you want to do. Okay, the very last thing to show you before I leave the software is this new Hook Brown tool. So if I go up to the blue drop-down here above the workspace, we have these rapid tools. Now, we've talked about these rapid tools in previous webinars. There's one for quickly calculating factor of safety for a rock slope. There's one for getting calibration of cable properties. The new one is this one, Hook Brown. So if I choose this Hook Brown rapid tool, it will fill up the workspace. Let's hide some of these pieces so we can have more space here. We don't need this either. So here's the Hook Brown tool. Okay, so what you see is a Hook Brown curve plotted sigma 3 versus sigma 1. This thing is designed to be quite interactive, so I could come here and change the extents of the axes to zoom in a little bit. Here are the inputs, so sigma CI, GSI, damage factor, so on. And again, this is interactive, so I can just hang my mouse over here and drag it to get different values and see the curve change. If I don't know what number I want to put in here, I can click here and it will open up a little chart to tell me what sort of typical values are. That's uniaxial compressive strength. This is GSI. You've probably seen these charts before. The parameters required to generate this curve are calculated from the inputs here. And if you want to know exactly how that's done, you can click on calculations and it shows you the equations and the references where they come from. You will also see here there's a best fit more Coulomb line, which depends on the maximum sigma 3. So again, you could change that here and get different best fit lines. And how that calculation is done is explained here as well. A couple of other things to show here. If I have a curve that I like, I can export it. So I could say export data, and it will actually export the curves to a CSV file or something that I can import in Excel. The other thing I can do is import data. So let's say you have lab data, sigma 1 versus sigma 3. If I say import data, It shows me the file format it's looking for. I can say import data. I have one on my desktop here. Right, so it plots a bunch of points here. You could go now and play around with these variables to try and get a match to the input data. We have plans for a future version where we'll automatically do a fit for you to some lab data. We haven't got that in here yet, but you can still look at it and play around with it yourself. When you're happy with your curve and you have the behavior that you want, you can actually just get the commands that are used by FLAC2D or FLAC3D or 3DEC. You can just copy and paste from here into your data file to get the hook brown behavior that you want. Okay, that is all I'm going to show in the program. And I will now minimize this and go back to the PowerPoint. All right, so the object tree I talked about. New plotting in FLAC2D I talked about. Here's an example of plotting the grid points where it might be useful. You can see the ones that are fixed. In this case, the pore pressure is fixed, and just to make sure that you've applied your boundary conditions correctly. Here's the triangular Voronoi generator that I talked about. One thing that I didn't talk about is the ability to now plot a line or a curve in the sketch using a table of points. So up until now, you had to import a DXF, a 2D DXF, and create points from that. Often you don't want to go to the effort of creating a DXF, and you just have a table of XY points. If I have a CSV file of XY points, I can just import that and it will draw the line for me. And that's super convenient. The Open Pit Wizard, I showed this already. The Hook Brown tool, I showed this already. Exporting structural element data to tables. There's another example of that. One thing I didn't show because I was in FLAC2D is that we have now added the ability to create moment thrust diagrams in FLAC3D. This was available in 2D in previous versions. In 9.4, you can now create these things in 3D as well. Okay, next thing, new constitutive model. So this is the CASM model, which actually just stands for clay and sand model. A unified critical state constitutive model applicable to both clay and sand, obviously. There's a relatively small set of material parameters, and it's relatively easy to do the calibrations. So it's actually quite a nice model. It's becoming more popular. You may have seen papers about this being used for modeling tailings dams and static liquefaction. It's definitely something that's becoming more popular. It is now built into FLAC2D and FLAC3D. There's a lot of detail here. If I click on the link for the documentation, everything is documented, all the equations and formulations. You can see here some curves of the yield surfaces versus different input parameters. There's a section here about how to do the calibration, and this is super useful. And then if you keep on going down, there are some actual examples. Here we go, right? So there's simple examples with like one zone and then more complicated examples of actual tailings dams. If I just click on one of these, you can get an idea for the kind of curves that we can generate with this new model. So I won't go into all the details, but it's all there in the documentation, and you can read up on it and look at the examples. Okay, new examples. In FLAC2D, we've added a bunch of new examples, and 3 of them are related to two-phase flow. Now, if you're an old FLAC user, you will probably know that there was a two-phase flow option in the old FLAC. We do not have a two-phase flow option in the new FLAC. Mostly it is unnecessary, because what we do have in the new FLAC is these more sophisticated soil suction models, right? Like Van Gunsten and things like that, that allow you to have more control over the relationships between the matrix suction and the saturation, and the permeability, and so on. And so we're able to reproduce a lot of the two-phase flow examples from old FLAC in the new FLAC2D by using these sophisticated soil suction models. So there's 3 new examples here. And I'm putting two-phase flow in quotes. It's not really two-phase flow, but we are getting the same behavior as we could do with the two-phase flow option in the old FLAC. There's an example related to axisymmetry, and then a couple of others that have something to do with fluid flow. This one, embankment consolidation, is especially useful to show you how to do these types of problems. And then just a few other little things. If you're a 3-deck user, it is now possible to import a griddle mesh and run a fluid flow analysis. That never used to be possible. I can import a griddle mesh. It will create all the flow planes on the joints and allow you to do this joint flow problems and also the matrix flow in a griddle mesh. If you're a MassFlow user, MassFlow is this software used for simulating cave mining. We've just done a lot of optimization there and speeding things up. It's also now possible to do dynamic axisymmetry in 2D, which didn't used to be possible. So we have been using this, our own consultants have been using this for modeling like blasting type problems and things like that. So that is now possible. And there are other new features as well. There's a detailed list of new features when you go to download the software. It tells you everything that's new. These are the highlights. I encourage you to download it and try it and go and have a look at what else there is. And that's all. Now happy to take questions.